Good morning, good afternoon, or good evening, and welcome to the next episode of Numbers with Nando. We're going to do things a little bit differently today. We're going to do a more discovery video, and we're going to discover as we go how to do something. And then at the end, I'll do a little summary example with just the procedure of how to do it. Okay, so a student asked me yesterday, how do I get an absolute value function to fit between 2 points? So we're going to look at that today. We're looking at a use case which you'll probably be thinking of, which is where the 2 points are at the same height. And then we'll do a harder one where the points are at a different height. Okay. So have a think for yourself. If we want an absolute value function to go through these, the red point and the green point, where should our vertex be? Now, an absolute value function, the gradient is the same on both sides. So the slope here is the same as the slope here, and we can make it steeper. But either way, the slope is the same, but negative on the other side. So if I have my little orange point here, where should I put this? At what x value should I put it so that the gradient will be the same? Okay, you probably thought it needs to be in the middle. If it's on the middle of these 2 points, here the gradient will be the same. Or even if we go lower, the gradient will still be the same, it will just be steeper. So there's lots of answers to the question. As long as your vertex is at the midpoint, you can do the gradient. You can put it at lots of different y values. So the midpoint of 2 and 8, 2 plus 8 is 10, divided by 2 is 5. So we need to shift it across by 5. And then we need to change the slope. So if we put it right down here, what's the slope? We've gone up by 3, across by 3. So the slope will just be 1. Okay, so there's one possible answer. Or if we wanted to do another one, also shifting across by 5, but maybe we wanted to go up by 2. If we go up by 2, we're going to have a different slope. So here the slope, the rise is up from 2 to 3, to 1, and across by 3. So the slope will be 1/3, up by 1, 3. Okay. Our domain on it, want it to be between 2 and 8. There you go. The x coordinate should be the midpoint. And then the y coordinate can be whatever you want it to be. But for a different one, for a different y coordinate, you're going to have to find a different gradient. All right, so far so good. Now let's move them out of the way and move on to the harder example. A point has moved upwards. Now if we go in the middle, it's not going to work. If we go across by 3, we have to go up by 5. Or left by 3, we're going to have to go up by 3. So the gradient's always going to be different. If we're on this midpoint here, the gradient is always going to be steeper on the right hand side and shallower on the left hand side. So this is not going to work. Nowhere on here is going to work. But there might be some other values that work. Well, here's looking pretty good at 4,1. The slope is the same. Well, there might be lots of values that work. Oh, that's looking good. Yeah, there might be here. The gradient's the same, 0.44 and negative 0.44. So the same but negative. So there's lots of different values which might work. And we need to discover what those values are. Okay, so let's just jump into PowerPoint and we can do a little bit of algebra to figure it out. Okay, I've just detached my screen here. Okay, so what did we want? We've got some point xy, but we don't know. We don't know what it's meant to be. But what we do know is that we want the slopes to be the same. So the rise on the right-hand side is up by 5 to y. So the rise is 5 minus y, and the run is 8 minus x. So the slope of this line is rise over run. And the slope of this line will be its rise, which is 3 minus y, and its run, which is 2 minus x. So the slope here will be the rise over run. Now we want this slope here to be negative of this one here. So what we want is this slope here to be the negative of that slope there. And this is going to tell us what x and y values are going to work. So what I want you to do now is pause the video and rearrange that equation to make y the subject. First you're going to have to multiply by the denominators. And then you get all your y's on one side, everything else on the other side. Factorize it for y, and we'll see what happens. So have a go at that. It will take a few minutes, so have a go, and then I'll restart the video. All right, so I'm assuming you've had a go yourself. So I want to times both sides by 8 minus x. And then both sides by 2 minus x. And we'll expand it all out. So we get 24 minus 3x minus 8y plus xy. And we get 5 times 2 is 10, but times negative 1, so negative 10 plus 5x plus 2y, and take away xy. I've multiplied everything by negative 1 as I went along. Okay, let's get everything over the y onto the left-hand side. So I've got my negative 8y plus xy. By the way, this is going to come out really beautifully. It's worth the wait. We add xy to both sides. Take away 2y. And on the other side, we've got a negative 10 plus 5x. Take away 24 plus 3x. Okay, and we'll simplify. Take away 10y plus 2xy equals 8x minus 34. Minus 34. I'll factorize the left-hand side for y. So I've got 2x minus 10. I've got 8x minus 34. Dividing both sides by 2x minus 10. Okay, so now we have an equation. We'll just simplify that a bit. Divide everything by 2. 4x minus 17 equals, sorry, divided by x minus 5. You still might not recognize what this is, so we're going to keep going, and you'll be surprised. It's quite lovely. I can rewrite the top as a multiple of x minus 5. 4 times minus 5 is minus 20, so I'll have to add my 3 to get back to negative 17. So what here? I've got 3 divided by x minus 5. Then the x minus 5's cancel with a 4, so then I've just got 3 divided by x minus 5 plus 4. But what equation is that? It's been shifted, it's got a gradient. Any guesses? Yes, that is a hyperbola. Crazy. So let's see what this looks like. I'm going to type it into Desmos. So we've just worked out that y has to equal 3 divided by x minus 5 plus 4. So what we're claiming is that anywhere on this black dotted line, anywhere on this hyperbola will work. Well, it does. All these points have the same gradient. Crazy. I'll just change it. Change point. So this orange point can only stay on that function. And wherever I move on the function, the gradients are the same. So that is pretty amazing, I think. Now, what do we actually do with this to write our absolute value function? We've found lots and lots of different x and y values that are going to work to be the vertex. But let's find one that we actually want to make our picture or whatever we're doing. So let's say we want to have this have the x coordinate of 4. What is our absolute function that will work for that? So we want it to be shifted across by 4. And we need to find out how much we should be shifted up by. We can use our function here. So if x is 4, we substitute in x equals 4. And it comes out as 1. 3 divided by -1, -3, plus 4 is +1. Okay, let's just see what this looks like for now. What should our gradient be? So to find our gradient, we're going to have to substitute in this value 8, 5. So y is 5. X is 8. We'll just go and arrange that. Oh, sorry. 5 minus 1 is 4. 4. 5 minus 4. Divide both sides by 4. M is 1. Okay, so I've already actually this 1. And there you have it. It really works. We have just found an absolute value function that goes through our 2 points. It's pretty cool. Same domain that we used earlier. Just another little practice of how to use the hyperbola we found to make an absolute value function. So let's pick another value. What if we wanted x equals 3? So we want a different absolute value function, but with an x value of 3. So it's not going to be as steep. In our equation of a value function, and so we want to just shift it across. We use our hyperbola, the function of our hyperbola, to find the y value that corresponds to this x value. So I'll substitute in x equals 3. And you can do the maths, but that comes out as 2.5. So this should be shifted up by 2.5. What should the gradient be? Substitute in you, so 8, 5. So let's just make that. Y is 5. Take away 2.5 from both sides. 8 minus 3 is 5. 2.5 divided by 5 is just half. gradient should be half. There you go. Using our hyperbola, we found another absolute value function that works. So that is pretty cool. You can make as many different ones as you like. And here is something I made earlier. Here's a slide along the hyperbola. All of the different absolute value functions which will work, which is pretty cool, I think. Okay, so to summarize, what we need to do is find the hyperbola which the vertex of our absolute value function lies on, and then we can use that point. Once we know that point, we can find the gradient that's required to make our absolute value function. Okay, I think it'll be best to do a little example now, and just using the algebra of what we found. But before we do that, let's just take note of something. This hyperbola here has an asymptote at x equals 5 and at y equals 4. So let's just see what that looks like. X equals 5 and y equals 4. I'm doing this because it turns out there's actually an easier way to find our hyperbola. You'll notice that this here is the midpoint of 2, 3, and 8, 5. This here is the midpoint. So to find the hyperbola that works, we actually don't need to do the method we did earlier of equating our slopes to find the hyperbola. We can actually just find the midpoint of the 2 points, and that will be the vertex of our hyperbola. 5, 4. 5, 4. Okay, and then we can just substitute in one of the values to find the slope of our hyperbola. So let's have a go at that with another example. To find the hyperbola that will fit through 3, 3, and 7, 1, we just need to find the midpoint. The average of 3 and 7 is 5. 3 and 1 is 2. That is our midpoint. Which means that the hyperbola, which our absolute value function is going to start on, some gradient is minus 5 plus 2. For example, that one, but that's not fitting to our point, so that's not right. We need to find the value of m that works. To do that, we substitute in one of our values, such as 7, 1. Y is 1, 7. 7 minus 5 is 2. Take away 2 from both sides, so that becomes minus 1. Now we'll multiply both sides by 2. M equals minus 2. Here we go. So that was a lot quicker than what I showed you earlier. But before we discovered this, we didn't know that the hyperbola was the way to go. But now that we know that, we can just jump straight to this method. The vertex of our hyperbola is the midpoint, and the slope you just get by substituting in one of your 2 points. Okay, so we have our hyperbola. Let's just make a little dotted line. We want our absolute value function to start anywhere on this hyperbola. Let's just say the value start at x equals 6. Now we can see straight away it's going to come out as y equals 0. But let's just do the math to check. Shift plus by a, up by c. So we want to start at the x value of 6. We use our hyperbola to find the corresponding. So I substitute in x equals 6, and y comes out as 0. Do the math yourself. So that comes out as 0. Now we need to find the gradient. What the gradient from there to there. We can substitute in that value 7, 1. When y is 1, it's 7, 0. 7 minus 6 is just 1. M equals 1. That's like 1. The gradient was 1, and it had moved up by nothing. That works. It's pretty cool. We find an absolute value function between these 2 points. That was a lot quicker than what we did before. Let's just try one more, which I'd like you to try yourself. What about when the value x is 5.5? Why don't you have a go at that yourself? So pause the video and try and make an absolute value function that fits through these 2 points with an x value of 5.5. Pause the video, go for it. Okay, I'll assume you've had a go. The form for absolute value function is this. Shift plus by 5. Use our hyperbola to find the corresponding y value. Simplify all that, and it comes out as -2. Which we could see from our graph anyway, when x is 5.5, y is -2. Now to find our slope, we substitute in our value 7, 1. 1, x is 7. 7 minus 5, let's just add 2. 3. 7 minus 5.5 is 1. Divide both sides by 1. Divided by 1.5 is just 2. Okay. Here you go. Isn't that cool? And of course we can put our domain on x to be greater than 3 and less than 7. And there we go. We have made 2 absolute value functions that fit between these 2 points, and you can find as many as you like. All right, I thought that was quite amazing. I actually didn't know that, how to do any of that until the student asked me yesterday, and I had just had a go at it by thinking about how we needed the slopes to be the same but negative. And then it was a great joy and surprise to me to find out that it all simplified to a hyperbola. So I hope you gained some satisfaction from discovering that too, and you also know a nice quick method which you can use anytime. So thank you very much, and join me for the next episode of Numbers with Nando.